Today we're going to talk about the properties of a circle. So we're going to identify and name the parts of a circle. This does seem like we're going backwards just a little, and that's okay. There are things in today's lesson that we haven't learned yet. We do know the definition of a circle. It's the set of all points in a plane that are equidistant from a given point called the center. So we had talked about how that helps us make a circle using a compass As we know from previous lessons, everything gets a name. So if you have a point, it has a name. If you have a line, it has a name. And there are specific ways to name certain things. So a circle is named by its center point. So if we look at our circle here, and let's say this is the center, and that center is the letter M. Well, that's a horrible M. Let me fix that. There we go. It's the point M. Then the name of this circle would be circle M. And you'll notice I put a dot in the circle, and that's usually put there so there's no confusion, because if you don't put the dot and somebody were to read your work without having reference, it looks like OM, or the length of segment OM. So we will see a dot inside that circle. We already know what a radius is, but what's its true definition? It's a segment with one endpoint at the center of the circle and the other endpoint lies on the circle. So we know that one endpoint is at the center, one is on, and that's the radius. We also know what a diameter is, but the official definition is a segment that contains the center of the circle and its endpoints are on the circle. So its endpoints are on the circle and it contains the center. So that's a diameter. A chord, we haven't talked about before, is any segment having its endpoints on the circle. So that means the diameter is a chord because its endpoints are on the circle. But any segment whose endpoints are on the circle is a chord. So that's also a chord right there. So the diameter is a chord. So why don't we call it chord? Because it's a very specific chord. It has to go through the center, and it is the longest available chord, because as you move away from the center, the chords get smaller and smaller. A secant is a line or segment that intersects the circle in 2 points. So it kind of sounds like a secant is a chord. I mean, come on, it's intersecting. But it says intersecting. It doesn't say its endpoints lie on it. So if I actually take this chord and I extend it out past the edge of the circle, then from the point on the circle to the point off the circle would be a secant. If this turned into a line, that too is a secant. So a chord will only stay inside the circle while a secant can go outside the circle. A tangent. Now, we've heard of tangent before, but we've seen it in the context of sine, cosine, tangent. We've seen it in the context of trigonometric ratios. This one is a line or segment in a plane of the circle, meaning that it's going to lay together. It can't go up and down while the plane is laying flat. That intersects the circle in exactly 1 point. So it could be a point that's already there, or it could be a point that's added, but it's a line that touches the circle just once. And our last definition is the point of tangency, the point where a tangent line intersects a circle. So let's just look at these last two definitions. So we know this is the center, and we have a line. We'll put it here. Actually, I'm going to use a straighter edge than what I have. So it looks like it touches it more than once, but my circle's not exactly perfect, so kind of imagine. So this is my tangent line, and that is the point of tangency. It's the one point that the tangent touches the circle. So our questions for today are: tell whether the line, ray, or segment is best described as a radius, a chord, a diameter, a secant, or a tangent of circle C. Now it says line, ray, or segment. Remember that the segments pertain to all of them, but going backwards, a radius can only be a segment. A chord can only be a segment, and a diameter can only be a segment. If you have a line or a ray, then it could also be a secant or a tangent. But if it's a segment only, it could be all five, but a radius could not be a ray, and a radius could not be a line. Okay, so I have segment AC, could be all five. So its point is on the circle, its point's at the center, that is a radius. Number 2, segment AB, so on the circle to on the circle. So a segment that is on the, whose endpoints are on the circle, could be a chord or a diameter. But it's going through the center of the circle, so it's a diameter. And remember, I know that point C is the center because that's the name of the circle. Now line DE. Okay, so now as soon as I get to a line, it can only be a secant or a tangent. That's all I'm looking for. Did it go outside the circle and touch it twice, or is it outside the circle completely and it only touches once? So here's line DE. It is completely outside the circle. It is touching once. That is the tangent. Line AG. Again, it's a line, so it's either a secant or a tangent. Does it go outside the circle and touch the circle twice, or is it completely outside the circle and only touching it once? So here's line AG. It's going inside and outside. It's a secant because it's touching it twice. Segment AG. So as soon as it's a segment, we're back to possibly being all five. So here is point A, here's point G. It's a segment whose endpoints are on the circle, not through the center, so this is a chord. Is point B the center of the circle or the point of tangency? Well, we already said C is the center because that's the name. So let's go look at B. Is B lying on the tangent? Yes, it is. So it is a point of tangency. So let's continue talking about the tangent lines. Common tangents are tangents touching two circles at once. So I'm going to use my straight edge here. Sorry for my head being in the way. And I'm going to touch both circles just once. And that is a common tangent. Now you'll notice that this tangent does not fall between the two circles. It's on the outside of them. So this is called an external common tangent. Do you see another external common tangent? Yes, you do. It would be up here at the top. Okay, this would be a common external tangent as well. And I'm just going to make it dashed so we focus on the one solid one for right now. Okay, so that's a common external tangent as well. So some people are like, well, wouldn't this tangent over here be external? I mean, it's outside the circles. But remember, it has to touch both circles. This line would not touch both circles, so it's not a common tangent. If I look at this a different way and I notice that the two circles have a common tangent that runs between them, this is called an internal common tangent. Sorry about that with the paper. And so, yes, there's a second one as well if you come over in this direction. Basically, the definition that causes the difference between external and internal is kind of weird, but here it is. If you connect the two centers of the circles and your common tangent crosses that imaginary segment, then it's an internal common tangent. If your common tangent does not cross it, it is a common external tangent. Tell how many external and or tell how many internal and or external common tangents to the circles. Well, I'm having a problem reading today. Tell how many internal and or external common tangents the circles have and draw them. So how many are there and draw them. Okay. Sometimes I find it easier to draw and then answer the question. So I can get a line to touch both of these circles here. So that's a common external tangent. And I can do the same thing at the top. I can get that to happen as well as the top. And so how many do we have? We have 2 external, and that's it. So if we look at number 2, the only way I can draw a line that's touching both circles at the same time is right here. So there's 1. And then it becomes a question, is it internal or is it... Sorry about that. Let me get this straightened out. What a mess I'm making today. Okay. So is it internal or external? Remember what internal's definition was. Internal has to cross this imaginary line that connects the 2 centers. Well, that's right there. This line does not cross that, so this has to be 1 external. Then on number 3, we have a line that will go here that touches both circles just once. So that's a common tangent, and that was a horrible drawing. Hopefully I don't mess you up too bad. Okay, then we have another one here. So far we have 2 external. There's one more. I'll let you take a look at it for a second, see if you can figure out where the one more is. Hopefully I gave you a hint. I've already said there were 2 externals. That means there was an internal, and it's right here where the 2 circles touch at that one point anyway. So it's 1 internal.